Question 8. A cross outlining 5 numbers as shown is placed on the grid. So what do you notice? Understand the relationship. From here to here is +8, right? Correct. Then from here to here is +1, which means that from here to here is +7, isn't it? And then from here to here is +9. And lastly, from here to here is +16. That is the relationship that you need to identify. I use the top number because it's the smallest number. Some of you will start with the middle number, which I think is perfectly fine. Okay? So if the sum of the largest and smallest of the numbers outlined is 204, complete the cross to show the numbers outlined. So let the smallest number be x. So your largest number, based on the relationship that we can identify above, will be x plus 16. So the sum of the largest and smallest is 204, means x plus 16 will give me 204. 2x equals to 188, and therefore x equals to 99. 94. When your math, this is why you always press calculator. So your top number is 94. Your bottom number is x plus 16, which will give me 110. Your middle number, we identify the relationship just now, it's just +8. So this is 102. That means this will be 101. This will be 103. Done. Like that is 3 marks. 3 marks. This is a number pattern question technically, but you just need to visualize it in terms of algebra. Okay? The cross can be placed anywhere on the grid. The difference between the product of the left and right number and the product of the top and bottom numbers is found. Show that the difference is always 63. So here I am going to copy out this so that I can use it. Again, this kind of question must always be solved using algebra. Okay? It must be algebraic proof. If you show using only numbers, which is what a lot of students do for this kind of question. So you tell me, oh, I show that 101 times 103 and 194 times 110 will always give me a difference of 63. You will get 0. Because all you have shown is for one particular case, not for all values of numbers. So to show that a difference is always 63, it can only be solved algebraically. Okay? So I start off with the same premise, right? Let n be the smallest number. Or let n be the number on top. Because they gave me top and bottom this time instead of left and all that. So this number is n. This number will be n plus 16. This number will be n plus 8. This number will be n plus 7. This number will be n plus 9. That's why that is what we will establish, right? Now, the one thing that you do need to establish is, while they tell you the difference is 63, you need to know which product is greater, right? How to check which product is greater? You take the value that you have at the beginning, right? So I take 12 times 28 is 336. I take 19 times 21 is 399. So left and right is greater. So that is what you must establish. This product here is greater, and this product here is smaller. And therefore, to find the difference of 63, you do have to take the left and right minus the top and bottom. So your difference here is equal to your left and right, which is n plus 7 times n plus 9. It's not n plus 8. Why did I write n plus 8? I'm hallucinating today. This is what happens when you teach for too many hours in one day. So n plus 7 times n plus 9 minus n times n plus 16, which is your top and bottom number, correct? There is nothing better to do, just go and expand and simplify. So you will get n squared plus 9n plus 7n minus plus 63 minus n squared plus 16n, not plus 16n, minus 16n. When you expand, please make sure you expand properly and change the sign. Right? And this will just, you should know that this is 16n, right? And therefore, this will just cancel with this, right? And this will just cancel with this, right? And therefore, the result is just 63. Therefore, the difference is always 63. Like that, 3 marks. You look at how free these 6 marks are over here. Okay? So top, bottom, left, right. That is what they mean. Let's move on. Then they test 4 marks over here. And a lot of students got very surprised by the question. But it's a very, very easy question. Tn is your general formula to a term. So what do we find? We first sub in n equals to k, isn't it? Because that is your term number. So tk is just equal to what? It's just equal to when n equals to k, which is k squared minus 1 over 3n, not 3n, but 3k minus 1. And they tell you this is equal to 15 over 4. Right? From here, very straightforward. I just cross multiply only what? 4k squared minus 4 is equal to 15 times 3 is 45k minus 15. Simplify this, 4k squared minus 45k plus 11 equals to 0. From here, you should be able to factorize this. Okay, if you're not sure how to factorize this very quickly, it's not difficult to factorize here because 11 is a prime number. So you should know that this must be minus 11 and therefore this will be minus 1 so that you get k minus 11 and k minus 4k minus 1. But if you cannot factorize this very quickly, then you just press your calculator and then learn how to work backwards. So you just get a quadratic and therefore you will get k equals to 1 over 4 or k equals to 11, which obviously you need to reject. Why? K is your term number. Your term number cannot be negative or cannot be a fraction. Your term number must be positive integer. It cannot even be just an integer. It has to be a positive integer. It cannot be 0. It cannot be negative. Right? There's no such thing as a negative term one. Right? I have term 1. I start from term 1. There's no such thing as a term 0 or a term negative term number. Okay? So k is equal to 11. And therefore, what they want is t, k plus 1, which is kind of weird. which is equal to T12, which is equal to 12 square minus 1 over 3 times 12 minus 1, which gives you 143 over 35. What a weird question at the end.